Hello there, welcome to the ASFM Maths Core June 2023 paper. Here we're looking at question 4. Show that 2 plus 3i over 5 plus I equals k 1 plus I, where k is a constant. Okay, so we're getting 3 marks for it, so we're going to have to show some working. So 2 plus 3i over 5 plus I. We're going to times top and bottom by 5 minus I, its complex conjugate. So we're going to get 10, I'm multiplying the tops together now. 10 minus 2i, add 15i plus 3, because I squared is minus 1. 25, add 1. So we're going to get 13, add 13i over 26. Separate these as two separate fractions. And we get half plus half I. So therefore that must mean that if I factorise out half, we get half brackets 1 plus I. So therefore it must be the case that k equals a half. And there we are. And we can also check this on our calculator as well. If we go into the calculator mode, we can do 2 plus 3i divided by, if we were to divide 1 plus I to the other side, then we get a half, which is exactly what we were expecting to get. So we've checked it on our calculator as well. Okay, given that n is a positive integer and 2 plus 3i over 5 plus I to the power of n is a real number, use your answer in part A to write down the smallest possible value of n. So I know that 2 plus 3i over 5 plus I can be rewritten as k lots of 1 plus I. So what I'm going to do now is I'm going to do 2 plus 3i over 5 plus I squared, just to see what that gives me. So it's going to give me a quarter, because we know that k is a half, don't we? A quarter, and then we're going to do 1 plus I, and that gives us 1, add 2i minus 1, so that gives us minus 2i over 4. So that's if the power was squared. Now I reckon if we square that again, we're going to get a real number. So if we now square that again, minus 2i over 4, or if we simplify it to start with, minus half I, we're going to get squared. Yeah, we're going to square it. So that'll be when we've already squared it, and now we're squaring it again. So that'll be when n is 4. We're going to get positive quarter times minus 1. So that's minus a quarter. So therefore, n is 4. Let's move on to part C. Now the complex number z equals a plus bi, where a and b are real constants. Given that z to the power of 10 is equal to this, and arg of z10 is this, determine the value of a and b. Okay, so this is a question where we're having to use those rules of arguments and modulus. So z to the 10, if we do the 10th root of this number here, let's see what we get. So 59049 to the power of 0.1, or 1 over 10, gives 3. So therefore z is just 3. So what I've done there is I've done the 10th root of that number, so get the modulus is 3. Now with the argument, it's slightly more different, because it's adding the arguments together makes the power. So let me just remind you that arg z plus arg w is arg zw. If I've done that with 2 z's, then I get arg z squared. Now if I've done that 10 times, i.e. added together 10 lots of arg z, we get arg z to the 10. So I'm going to rewrite this as 10 arg z equals minus 5 pi over 3, and divide both sides by 10 and get minus pi by 6. So that's my argument. So therefore the complex number can be written in the form 3 brackets cos minus pi by 6 add I sine minus pi by 6. And then I'm going to expand the brackets. 3, make sure you're in radians mode first. 3 times cos minus pi by 6. And that gives an answer of 3 root 3 over 2. And then add, I'm going to change it now for sine and expand the 3 with the back part and multiply it by I, minus 3 over 2I. There we are, that's the value of A and B when it's written in Cartesian form. And there we are, that's the answer for question 4, worth a total of 8 marks. Let's now move on to question 5.